Hello students, welcome to today's lecture. In today's lecture we are going to discuss about the second bit, that is a binary communication channel. Learning objectives: binary communication channel, binary symmetrical channel, and the numericals on binary symmetrical channels. So first thing is, what is discrete memoryless channel? So discrete memoryless channel is a statistical model with an input x and the output y. That is a noisy version of x. Both x and y are the random variable. So this is a representation of a discrete memoryless channel where your x is represented by, where x represents the input signal and y represents your output signal. Then the conventional way of describing a discrete memoryless channel is to arrange the various transposition probabilities of the channel in the form of matrix as given below. So this matrix is called as a channel matrix, which gives us the relation between the input channel and the output channel in terms of the probability. Capacity of a discrete memoryless channel. The channel capacity of a discrete memoryless channel is defined as the maximum mutual information, that is IXY, in a single use of a channel where the maximization is overall possible input probability distribution as Pxj on the x. The channel capacity is commonly denoted by C, thus we can write the channel capacity as maximum value of the mutual information. The channel capacity C is measured in bits per channel use or bits per transmission. Then next part, binary communication channel. The case of discrete channel where only two symbols are transmitted is called as a binary communication channel. So this is a representation of a binary communication channel where we are having only two inputs. The first input is x0, second input is x1, and we are having only two output, that is a y0 and y1. As we are transferring only two symbols, this is called as a binary communication channel. Now here one thing is very important. If you are transferring the signal x0 and we are receiving the signal y0, the probability of this particular channel is given as y0 by x1. Second condition, if you are transferring the signal x0 and you are receiving y1, the probability of this particular channel is given as py1 by x0, that is y1 received when x0 is transmitted. Now similarly is a condition for transferring x1. So x1 is transmitted with the probability of px1. So if you are transferring px1 and you are receiving y1, the probability of this channel is given as probability of y0 by x1. And last condition, when we are transferring a y1, when we are transferring the x1 and we are receiving y1, the probability of this particular channel is given as probability of y1 by x1. So in this way we represent a binary communication channel where the values written on the channel represents the probability of what is received and what is transmitted. Now next is the probability equations. So by the same we find out the equations for the probability. Now as y1 is because of two inputs, that is the x0 and x1, which is transmitted with the probability of py0 by x1 and py0 by x1 respectively, the probability of y0 is nothing but the addition of probability of x0, this is x0, transmitted over a channel with the probability of y0 into x0, therefore we are taking its multiplication, plus probability of transferring x1 with the over a channel with the probability of y0 by x1. So these two terms get added and it will give you the probability of y0. So that's what we have written over here. Probability of y0 is equals to probability of y0 by x0, this probability into x0, plus probability of px1 into probability of y0 by x1. So this will give you probability of y0. Same way we are finding the probability of x1. Then in the matrix form, the above equations are written as py0 upon px1 is equals to px0 into px1. This is a second matrix, and this complete matrix is called as the channel matrix. So this matrix gives us the relation between the probability of input and the output. Y0 x1 is the probability of first channel, y1 x2 is the probability of a second channel when the received signal is y1 and the transmitted signal is x0. This represents the probability of next channel, and this one is for the last channel. Next is binary symmetrical channel. Now binary communication channel is said to be binary symmetrical channel if probability of y0 by x1 is equals to probability of y1 by x1. So here the probability of y0 x1 is replaced by p and probability of y1 by x1 is replaced by p. Now we know one thing is very important, that the probability of received signal is always equals to 1. So the probability of one channel, if it is equals to p, then the probability of second channel is said to be 1 minus p. Therefore the probability of channel y0 by x1 is equals to 1 minus b. So the same is applicable for the second condition. So here we are replacing the values of y0 by x1 by p, and y0 by x1 is replaced by 1 minus p. And similarly the probability of y1 by x0 is replaced by 1 minus p, and y1 by x1 is replaced by p, and this is the channel matrix for the symmetrical channel. So what is symmetrical and non-symmetrical channel? Symmetrical channel is a channel where p y0 and x0, probability of p y0 x0 is equals to probability of y1 by x1, and if it is not equals to, or if they are not same, it is called as a non-symmetrical channel. Capacity of a binary symmetrical channel. For symmetrical channel, the formula for finding capacity is given by C is equals to 1 minus P log to the base to 1 by P plus 1 minus P log to the base to 1 divided by 1 minus P. So this formula, just note down this formula. This formula is very important for finding the channel capacity of a symmetrical channel. Similarly, for non-symmetrical channel, the formula for finding non-symmetrical channel capacity is the Murgos method. So what we are doing in Murgos method, this is the channel capacity which we have already found out. So we just rearrange the equation and we put the equation comes out to be P y0 by x0 into P y1 by x0, P y0 by x1, P y1 by x1 is written as, is multiplied by q1 by q2 is equals to P y0 by x0. We are just taking this value and then we multiplied by log 2 with the same value. We are taking the log of same value plus P y1 by x0 log to the base 2 of P y1 by x2. So in this way we have written this equations, or we just rearrange the given matrix in this format, and once this value is rearranged, our next task is to find out values of q1. So by solving this, by taking matrix multiplication, we find out the values of q1 and q2, and then for finding the channel capacity, the formula is log to the base to 2 raised to q1 plus 2 raised to q2. So we find out the values of q1 and q2 from the above equation, and we put the value in the channel capacity formula, and it will give you the channel capacity for the non-symmetrical channels. Example. So this is the first example given to us. So find the channel capacity of the cascaded channel. So this cascaded means we are having two channels which are cascaded format. So this is your first channel and this one is your second channel, first set and second set. So for the first channel, your input is x1 and the output is y1. For second, your input is y1 and the output is x1. Now one thing is very important. Whenever a question comes to you, your first task is to find out or identify whether the given channel is symmetrical or non-symmetrical. So as these two values are same, that is your y1 y0 by x1 is equals to y1 by x1, this is called as a symmetrical channel. Okay, so we have to apply the formula for the symmetrical channel only. So the steps, the first step is to find out the relation between z and x. So for finding z by x, what we have to do, p z by x we have to find out. So first, for finding z by x, we find out the relation between y and x and the relation between z and y. That is the relation for the first channel and for the second channel. So this is the condition for the first channel. So for the channel matrix for the first channel is given by p y by x. There is a relation. So we are just putting the value of y1 by x1, y1 by x2, y2 by x1, y2 by x2. We just copy the value from the given matrix. So this will give you the probability matrix for y by x, and similarly we are finding the probability matrix for z by y. So for z by y, we are taking relation between z and y, the probability of z1 by y1, probability of z1 by y2, probability of z2 by y1, z2 by y2. We just note down the values. So once these two values are with us, we find out the final values of probability of z received when x is transmitted. The z by x is nothing but the relation multiplication of z by y into y by z. The y by z values are with us, z by y values are with, we put on the values, and as these two are in the matrix format, we take matrix multiplication, and your probability of z by x comes out to be, after matrix multiplication, is this value. So once the p z by x is with us, we go for second step. The second step is to find out the probability of only z1 and probability of z2. So the probability of z is nothing but probability of x into probability of z by x. Okay. Now probability of z. So this is the value of x. X is 0.6 and 0.4, that is given. Probability of z by x, we have just find out the value, and by solving this, what we come to know, the probability of z1 and z2 is 0.24 and 0.476. This is the probability of z1, that is a 0.7524, and z2 is equals to 0.476. Then last one is to find out the channel capacity. The formula, as this is a symmetrical format, the channel capacity formula is 1 minus p log to the base to 1 by p plus 1 minus p log to the base to 1 divided by 1 plus p. So we have already found out the probabilities, and we put on the values of probabilities. So the probabilities, we put on the values for the probabilities. The probability is 0.62 and 0.38. Now by putting the values of probabilities, my channel capacity comes out to be 0.042 bits per symbol. So in this way we find out the probability, or we have find out the channel capacity. Second one is the example. So find the channel capacity. So the given example given to us is of a non-symmetrical format, because these two values are not same. Okay, so this is an example of a non-symmetrical channel. So for non-symmetrical channel, we are going to apply which formula? We are going to apply the formulas of the Burgos theorem. The solution, so first is find out the channel matrix P. Second step is form PQ matrix and obtain the values of a Q. And third one is obtain the channel capacity by Burgos method. So let's begin. So from the given matrix, we form the channel matrix P as Py1 by x1, Py2 by x2, Py2 by x1, Py1 by x2. So this is my channel formula for the channel matrix, and from the given channel diagram, Py1 by x1 is 0.7, Py2 by x2 is 0.2, and likewise we put all this value in the formula, and we are getting the channel matrix as 0.7, 0.2, 0.3 and 0.3. So this is the channel matrix, that's a P. So once the channel matrix is with us, we go for second step, that is to form PQ matrix and obtain the values of Q. So this is a representation of a PQ matrix, or the equation. We put all those values. So this is the values of a channel matrix in Q1, Q2, and this relation we have to write down. So we just note down the values. That's a 0.7, 0.3, 0.2, 0.1 into Q1, Q2. This is the value. Then our next task is to find out or solve this particular equation. So after solving these two equations, our modified version is, we have taken cross multiplication over here, the 0.7 into Q1 plus 0.3 into Q2, 0.2 into Q1 plus 0.8 into Q2 is equals to the solution or the answer of this particular matrix. Okay, and then we have to make comparison. So after comparing, what we come to, as these two are equal, so what we come to know, the value of this is equals to this one, and similarly the second value is equals to second value. So these two are the relations which we find out. And then as to these two are the symmetrical equations, we find out by using the these two are the simultaneous equations. So from simultaneous equations we can easily find out the values of Q1 and Q2. So the Q1 and Q2 comes out to be, this is the value of Q1. Q1 comes out to be minus 0.75 and Q2 comes out to be minus 0.788. And then finally we have to find out the channel capacity. So the formula for channel capacity is log to the base to 2 raised to Q1 plus 2 raised to Q2. We put on the values of Q1 and Q2, that is, Q1 is minus 0.975 and Q2 is minus 0.588 bits, and the channel capacity in this case comes out to be 0.918 bits per symbol. So in this way we have find out the channel capacity for the non-symmetrical channels and as well as for the symmetrical channels. Thank you for listening to my video. Thank you.